Hi everyone, this is Vikram from CyberPeace Foundation. Uh, Today we have Mr. Champika Vijayatunga and Mr. Samiran Gupta from ICANN. So ICANN needs no introduction, and we have uh, our eminent panelist for a workshop on DNS abuse. So Champika and Samiran would be actually taking you through the presentation and explaining about what is DNS and what all is happening in this world, in this part of the world. Champika, over to you. Welcome, Samiran.
Hi, thank you, Kumar, and welcome all. My name is Samiran Gupta, and I'm based in New Delhi, India. I'm the head of India for ICANN, and my colleague Champika, who's going to conduct the DNS abuse session, is based in Brisbane, Australia. So, although Kumar just mentioned ICANN does not need any introduction, it's best for me to say a couple of words make a very brief introduction, and then hand it over to Champika. I don't want to stand in the way of his sort of session with you. So ICANN's role, as many of you may be aware, is to coordinate the unique identifiers of the internet, which is mainly the domain name systems and some of the protocol parameters that go along with it. Of course, when Champika does his session, you will know in detail how all of this happens and what are the kinds of abuse that we classify as domain name abuse. But just continuing with the introduction very quickly. So ICANN is organized as a non-profit and organization, and it is essentially community-led sort of initiative. So hopefully after today's session, many of you, if you're not already participating in ICANN-related activities, will find the interest and the time to join us in maintaining the unique identifiers of the internet. With that, let me hand over to Champika, and the floor is yours, Champ. You're on mute.
Yeah, thanks, Samiran. Yes, and welcome all. Very happy to talk to you, and thanks Vikram and the team for all the support as well. In the beginning, actually, I did ask Vikram about today's audience, and I believe based on the information that I got from Vikram, there are some of you are quite familiar with DNS, but then at the same time there are also some newcomers as well. I mean, who are quite new to DNS as well. So it's a sort of mixture of the crowd. So I will try to adjust the pace based on everyone's need as well. But feel free to let me know if you have any clarifications and so on. Let me also actually share my slides. I hope that you can see the slides, and I hope that you can hear me and also see me as well. Yeah, so today, as you know, our main topic is going to be on DNS abuse. But before we really get into the DNS abuse, I think for everyone's benefit, I'll quickly go through some quick recap of DNS, and then we can go into the abuse. Now, in a nutshell, DNS, as we all know, it's a distributed database, and basically, the data is all maintained locally, but availability globally as well. And this is quite important because, and also the other thing is that DNS is a hierarchical database. Now, there are a few elements that gets involved when it comes to DNS. One is resolvers, or simply the clients who send the queries to the name servers. So we have the servers, or simply we call name servers or DNS servers, that answers those queries for those clients. And then to optimize these answers and the performance, we have things like caching. And then also, actually, there are other redundancy mechanisms in DNS and load distributions and load balancing and so on as well. So these are not, very typically the key elements when it comes to DNS. I earlier told you that DNS is actually a hierarchical system or a database. Now, in this diagram, you can see how this hierarchy is all sort of, structured. You can see there are different levels. Now, top of this hierarchy, we have something called the root. Now, root is quite, important element in this whole system. And the root itself is a database, and simply in DNS terms, we call it as the root zone. And underneath the root, we have things called top-level domains, or simply called TLDs. Now, DNS has been there for quite a long time. The initial RFCs were sort of, defined back in early 1980s or so. So it has been quite a long time. But then over the time, there have been a lot of RFCs in relation to various standards within DNS. So if you really consider the, the namespaces within DNS, we have obviously underneath the root, we have top-level domains, as I said earlier. And over this time period, even the top-level domains have evolved quite a lot. Very early days, we used to have generic top-level domains, the legacy ones, like, for example, like .com or .net and so on. And then we also had country code top-level domains, like, say, for example, like in India, you have .in, for example. That's the country code top-level domain. And then similarly, there are over 300 or so at the moment for different countries and territories. And these are like ISO standard, ISO 3166 two-letter country codes. And then also there have been in the last decade or so, we have also been delegating something called internationalized domain names. Here, actually, you can see there is some ASCII label here, starting from XN --. But actually, this is what we call a puny-code. But in actual fact, that is a internationalized domain name. So this could be in a certain local language script. For example, if you consider in India, there have been several local language scripts have been delegated under the root. Around 15 or so different, different language scripts have been delegated as top-level domains. Similarly, out there in the world, there are many of these top-level domain IDN strings have been delegated now. Then we also have actually in more recent times, like after 2012 or so, these new generic top-level domains have been delegated. So, for example, here you have something like .coffee, for example. There are cities like .Melbourne or .Tokyo, and then there are different professions and so on. So there are quite a lot of these as well. over 1,000 or so at the moment. So you can see that, when you think about this whole layer of top-level domains, that counts, around 1,500 or so top-level domains at the moment. So the TLDs have really grown over the last 40 years or so, from a few TLDs to over 1,000, close to around 1,500 or so at the moment. So you can see, it has evolved quite a lot. And then obviously, when the space getting bigger and bigger, we also have to understand that the security aspects, the abuse aspects also actually becomes more and more, because there's a large playing field for the miscreants or the cyber criminals as well. And then obviously, we have the second level domains. When you go further down the hierarchy, you can see the second level domains and third level domains and so on. Now, when you consider the DNS components at a glance, there are, again, key elements. I briefly explain those. We have clients who send the queries. So typically, if you see a client device, we have, or the client application, we have things called stub resolvers in that. That would make basically a query to what we call a recursive resolver. And this recursive resolver is typically operated by the internet service providers, network operators, and so on. Or there are also actually public recursive resolver operators who also operate as well. And also, there are quite a lot of enterprises, organizations who also tend to, they run their own recursive resolvers nowadays. And so that's the recursive function. Sometimes we also actually call this function as a caching resolver, or caching server, and so on, right? Then we also actually have things called authoritative servers. You can see in this diagram. These are also actually managed by different other entities who actually run DNS name servers, and those servers has, they have the authority to run those. Basically, I'm talking from the server and the data point of view as well. So call those servers as authoritative name servers. For example, like earlier I was talking about the root zone. So we have root server operators who actually keep the root zone in the root servers. And then, so basically, that is an authoritative server. If you consider the root server, that's an authoritative name server, because they are authorized for the root zone. And similarly, then we also have TLD servers. So TLD servers are authorized for the TLD zone, and so on. And then recursive servers would send the queries to all these authoritative servers and receive the answers from them, and then send back to these clients who requested for that basically. And then for performance aspects, these recursive resolvers would keep the answers in the cache or in the memory. So that's the key sort of components that involve in the DNS, and also operationally there are different parties who involve in managing these different aspects of DNS. So if you really consider the DNS ecosystem, it is quite large, it is quite complex, because there are many players involved in managing these different entities and different components. So now, again, from a DNS abuse point of view, it is very important to understand the whole DNS ecosystem that we discussed, and also actually the contractual relationships that exist between these different players. So this, you can see in this slide, there are different entities, parties, and then also actually you can see those contractual relationships as well between these different entities. Now, if you simply take, say, a registrant, right? Say, for example, if you want your own domain name, you are the basically registrant. So if you want to get or buy your domain name, you could be either going to a domain name reseller or a registrar. Now, either way, whether you get it from a reseller or registrar, you will have an agreement with that party, right? So this is where you would agree to some terms of services, conditions, and so on, and that's basically an agreement with them. And then there are entities called domain registries. Now, earlier I was explaining to you about the top-level domains. So all those parties who run these top-level or operate these top-level domains are called top-level domain registries. And we only have one particular registry who manages a given top-level domain. So we don't have multiple registries running a single domain, a single TLD, right? So we have a single entity that manages that given TLD, okay? But when it comes to registrars, there can be multiple registrars. So even if you take a single, within one registry, within one, say, consider .com, for example. So we have a certain entity that operates .com, but then there can be several registrars, that actually that is associated with that particular registry. Okay, and then again, there can be several or multiple resellers associated within a certain registrar as well. So we have to have agreements. They have to have agreements or contracts between all these parties. And then also you can see actually in this end, you can also see ICANN, right? ICANN has also got contracts with, you can see these registry operators and also actually with some of the registrars as well. Now, when it comes to the ICANN contracts with the registry operators, ICANN has got contracts with the generic top-level domain registry operators. We do not have contracts with the country code top-level domain registry operators because they are independent countries as such. So the country code top-level domain registry operator would actually basically they decide their policies that would be applicable within their CCTLD. Okay. But when it comes to the contractual agreements, say with GTLDs, so these are defined in the GTLD, what we call this registry agreements. So you can see this RA or the registry agreements. So these are defined in this agreement that the top-level domain registries that would agree with ICANN. And in the same way, there are certain registrars who are also actually called ICANN accredited registrars, and then they would have actually the RAA or registrar accreditation agreement with ICANN, so that they can follow the terms and conditions of that registrar accreditation agreement as well. So this is sort of and contractual agreement as well. So why I'm actually trying to explain this contractual agreement process, especially when it comes to handling DNS abuses. This sort of having some understanding about this contractual relationships is quite helpful, because that to which party, to which entity that you should be lodging a DNS abuse complaint, right? Because if there is some certain DNS abuse, you have to lodge certain complaints related to those DNS abuses. So you say, for example, if there is a certain phishing domain, or if there's a certain malware domain or a spam domain and things like that. So you may have to find the appropriate registrar or reseller and so on, and then lodge a proper abuse complaint. So you have to know exactly what would be the conditions in that agreement, what would be the terms and services and so on. And then these things will be quite helpful actually when it comes to DNS abuse handling. All right, so I hope that you got some clarity about different entities who are in this whole DNS ecosystem, and also actually the different relationships, especially in terms of contracts. All right, now considering the various sort of DNS abuses that happen nowadays, you can see that this is this is now, of course, you can see there are a number of common ones are listed here, but then again there are much more as well. This is not the whole list as well. Generally, you'll see a lot of domains are being registered for various abusive or maliciously malicious purposes. For example, like selling counterfeit goods, or various data exfiltration type of attacks, and then illegal pharmaceuticals, and also actually malware command and controls, and the list goes on, right? So we see that there are lots of abuses do happen in the DNS actually in relation to various type of attacks. Now we also have to understand actually why DNS is actually an attractive target for the miscreants. Now, first of all, DNS is a public sort of facing infrastructure, right? We have domain names, and also actually, if we want to actually go to a certain website, we need DNS, right? If we want to send an email, we need DNS. If you want to actually use your mobile apps, we need DNS. So pretty much all these things what we do, we really have to have DNS. So this is also why actually DNS has become more of an attractive target for the cyber criminals. And also actually you can see that there are lots of processes in the DNS quite automated, right, and rapidly provisioned. And say, for example, like nowadays, you can buy a domain name within a very short time, online as well, right? You don't have to physically go to any place to get a domain name. You can do it online straight away, right? And then this can be also automated as well. So sometimes, say a registrar would probably not know, maybe this domain name was actually acquired or bought by a human or by a bot as well, right? So always that's possible. And also actually generally in terms of correspondence, say for example, if the registrant is communicating with the registrar, mostly this communication happens through email, right? And as we know, email can be compromised as well. It is possible that there could be email compromises through various phishing attacks and so on. So there is always possibility of that risk. And then registrant is also actually responsible for the registrant's data accuracy as well. It is actually the registrant who has to update that information in the registrar system. So registrant is given the credentials and you log in and provide these updates. This could be about your DNS servers, this could be about your mail servers and so on. So registrant will have to take that responsibility and update that. Or registrant obviously can have another party, right, a proxy party, who will or outsource it to another party who can do that behalf of the registrant. But ultimately, it is the registrant who should be responsible for that data accuracy. So, because of these reasons, obviously, if the attacker can somehow manipulate or basically compromise the registrant, then there is always possibility that the data can be changed as well. Now, also other thing is that there are plenty of inexpensive registrations nowadays. For very small amounts or sometimes even free, right? You can register domain names. Different registries, they have different business models, how they run. So they could be offering some free registrations for a certain period of time, maybe for a year, for example. And then the attackers could be taking advantage of that because, they to do an attack, they may not need this domain for a very long time, right? They may not need it for years. They may only need it for a certain, small time period. So if they can, get that advantage, say if there is some registry is offering for a free registration for a year, easily that that can be taken into some advantage and then go ahead with that abuse, right? So this is good for, in terms of inexpensive registration, it is good for the consumer, but at the same time, it is also actually good for the attackers as well. So that's something that we have to understand. So these are, some of the reasons why actually, DNS, the domain name registrations are quite attractive targets for the miscreants. Now, further going into various, DNS threats and abuses. Now, first of all, trying to, if you go back to earlier, I was telling that, the initial RFCs, the request for comments, the standard documents of DNS that was written way back in early 1980s. So, and also actually, as you can see nowadays, there are so many different entities, as I explained to you, in this whole ecosystem. There are so many parties involved in managing DNS as well. So over the years, it has evolved. So this has also become the whole domain name system to be quite complex as well. The management of this system, also actually, various elements that are involved in this whole DNS ecosystem is quite complex. So this also actually would lead to various attacks as well. And also because considering that the protocol itself, long time ago when it was designed, the protocol itself did not have much of, say, security features built into the protocol itself. Say, for example, if you consider the query response, the data integrity aspects, it wasn't defined in the original protocol itself. So you don't see a protection against data corruption in the DNS, right? I'm talking about the DNS data, right? So it was always possible to corrupt DNS data. So you have to have, if you are to protect DNS data, you have to have some other mechanisms on top of the usual, the protocol. Say, for example, you may have heard about DNSSEC or the DNS security extensions. So DNSSEC is a security mechanism where we can protect the data, the integrity, and the also, the integrity, the authenticity, and so on. So you have to have these sort of security mechanisms on top of that to make sure that we can protect those. But if you really take the protocol itself, that doesn't really have the usual queries and responses, doesn't have data protection against data integrity. In the same way, the queries and response doesn't have the protection against confidentiality aspects as well. Okay, so for example, earlier actually I was telling that if I want to visit a certain website, I have to send a query to the recursive resolver, operated by an ISP or another party, right? I need to send that query. So this query goes in plain text or in clear text. So if an attacker captures these data, the packets, basically it is possible to know exactly where these packets are going to, or basically the related metadata can be obtained. So which websites that I'm visiting and so on can also be captured by the attacker. Right. So basically, there is no confidentiality in terms of DNS data as well. So there are, of course, you have to have extra other protection layers if you really want to protect these. Now, also actually in DNS, you will see that there are namespace risks involved. So when I said namespace, basically, I explained to you that DNS is a hierarchical system, hierarchical database, and then all those different components of that database is managed by different parties, different entities. That is also why we are telling that DNS is a distributed database. So one party doesn't have to manage the whole system itself, right? So there can be several parties who are managing different components of this database. So there are risks involved in this. So if a certain party is responsible for a certain namespace, and if they do not manage their own namespace or the database properly, then there could be always a risk, right? Now, earlier I was also telling you about the internationalized domain names, so IDNs. There are risks involved in that namespaces. I have given you an example here. If you consider this domain example.com, now this is a typical Latin-based script, basically English English language scripts, and it is also actually can be defined ASCII, of course. It's an ASCII domain, but we can also have an IDN or an internationalized domain name, which actually pretty much look similar to this. So you can see, by looking at this, it looks example, .com, but it is not the same, because you can see that this E has a certain accent. So it is not really the English alphabet E over there, right? So if you really convert this IDN to an ASCII label, it really becomes this XN hyphen hyphen and then the rest of the thing, right? So this is the ASCII domain corresponding to this IDN. So even though to a user it looks similar to example.com, in actual fact, the query would resolve based on this ASCII string. So user might think that it's really going to example.com, but in actual fact, the query will go to somewhere else. So this is typically a risk that you can see also in the namespace as well. So because there are many IDNs and so on, so these kind of risks can happen quite often as well. Okay. So just need to be aware of these kind of things. So because there are plenty of abuses do happen in the internationalized domain namespaces. And then sometimes the users by mistakenly, we may not type the words, the domains correctly. This is actually, if you type example.com as like this, M and A is sort of swapped in, between those characters. So without knowingly, the user might get to a different place or a different domain, different namespace. And then this is what we call type of squatting, right? So some miscreant, some attacker could actually take this behavior and then try to abuse that and gain something out of that, right? So these kind of abuses do happen in the DNS. And then further moving on, there are lots of redirection sort of threats and abuses do happen in the DNS. So this is where basically, the attacker can redirect or change the domain name servers to point to attackers control authoritative servers. So earlier when I was explaining to you about the different DNS components, I also did mention to you about recursive resolvers and authoritative servers. So if attacker can easily control an authoritative server and then redirect those queries to those specific authoritative servers. Yes, actually there is actually a point, a question on the DNS spoofing aspects as well. So basically, DNS spoofing is the same thing. Earlier I was telling you about the phishing. So you gain control of a certain domain, right? You gain control of a certain domain and mislead the user to go to a different place, right? So this is related to the spoofing, phishing, and so on, right? So basically, user would get a wrong understanding that user would think that it's going to the right place, but in the end, it gets directed to a wrong place, right? So basically, from attacker's perspective, attacker is sort of carrying out some sort of impersonation here. Okay. Yeah. So redirection, right? So, but redirection also can happen through some hijacking aspects as well. So that is actually here you can see the resolver hijacking. So here we are referring to say getting control over your recursive resolver. Now, I'm an end user. I send a query to my recursive resolver run by ISP. So I'm assuming that my queries are going to my ISP, right? I have a certain trust relationship with my ISP, and then my queries are going to my ISP, and all in my device, my ISP's DNS servers are all defined, right? Configured. So I am assuming that all my queries are going to my ISP's DNS server. But by some means, if the attacker can change that without me knowingly, say for example, to some DNS servers that is controlled by the attacker, then I might think that my queries are going to my ISP, but in actual fact, the queries can go to the DNS resolvers that is actually operated by the attacker. That can happen. Say, for example, this can be done through a malware, for example, right? So user can be taken to a certain malware site, and then once user get to a malware site, the malware can get downloaded into the user device, and then the malware can change the DNS settings in the user device without, user may not know about this change because it was all changed by the malware. So user might think all these queries are still going to ISP DNS servers, but then in actual fact, the queries could be going into the attacker controlled DNS resolvers. So this is a typical case of a resolver hijacking, right? So these sort of things can happen as well. There are some, of course, there's a question whether it is possible to hack the cell phone by IMEI numbers. I mean, always it is possible. Of course, this is not relevant to the DNS. Of course, that is different context here. It is possible, right? For example, even the MAC addresses can be spoofed as well, right? So there can be in different layers of TCP/IP, like talking from a broader point of view from protocol itself. So because in internet data communication, we use TCP/IP. In TCP/IP, we have different layers. We have application layer, we have transport layer, we have the IP layer, then we have the physical layer. So spoofing can be done, and we have identifiers in all these different layers. Specifically from DNS, we are talking in the application layer, right? Because DNS is in the application layer. But so DNS is an identifier in the application layer. But then also there are identifiers in the other layers of TCP/IP. There are identifiers in the transport layer, like the port numbers and so on. There are identifiers in the IP layer, the network layer, like IP addresses. There are identifiers in the physical layer, like the MAC addresses, as I told you. So it is possible to actually spoof these identities as well, even in the other layers, right? But of course, in this we are focusing in the DNS, right? Domain name system, which is actually in the application layer. Okay. All right. I'm just actually to see some of the questions that are coming. Yes, some of these questions, of course, related to .onion, for example, that is a different context, right? So it is not really, you don't have the architecture is not really based on the DNS itself, right? So that is different. And then we also have a question on the sites being accessed using public, how the path on the sites being accessed is being changed by hackers. Oh, redirect. Yeah. So that's actually the last question is really referring to the hijacking aspect that I just discussed. So when just try to understand how a DNS query gets resolved. Say I'm a user, right? So if I want to access a certain website, I have to ask, okay, give me www.example.com, right? So basically, that is the domain name. But for the query to get resolved, we have to really have the IP address, because in the TCP/IP layer that I just mentioned to you, we need to have the IP address, right? The data communication happens in the IP layer. So DNS, or the domain name system, is to that mapping, right? Because as humans, of course, we can't understand or we can't remember all the IP addresses. So that is why we have DNS to to deal with it quite easily, right? So so when I want to go to a certain website, obviously my device, my application needs to know the IP address to get to that web server, right? If I want to go to the www.example.com, I have to know the IP address of www.example.com. So this is why I send a query or DNS query to the recursive resolver asking the IP address of that particular web server, right? So that's what we call a DNS query. So basically what I need is the IP address. And then the recursive resolver has got a job to go and talk to various other authoritative servers out there, like the root servers, the TLD servers, and so on, and trying to find me that IP address. And then once I get the IP address, then obviously I can get to that particular web server, because that's basically in the IP layer itself, right? So that's how the query gets resolved. So during this whole process, the attacks can happen in many ways, right? As I said earlier, we are talking about the whole TCP/IP stack, the whole number of layers. So many attacks can happen in different layers. But for today's discussion point of view, our focus area is the DNS. So the attacks that relates to DNS. So that is what actually I'm just trying to focus on, to different type of attacks that can come within the DNS aspects. Okay. All right. So, and then we also have denial of service type of attacks. So simply, this is what we call DDoS, or denial of service DOS attacks, and then when it becomes distributed, we call DDoS, right? Much the severity becomes much more. So here, the whole point is that the attacker would try to overload a certain server, right, with a lot of queries. So if the attacker's objective is to bring down a website, then you would send a lot of queries to a web server. If the attacker's objective is to bring down an authoritative server, the attacker can create a lot of queries to a certain authoritative server or to a recursive server, and so on. So the whole idea here is that the victim would get a lot of traffic, and then the victim may not have enough resources in terms of the bandwidth, in terms of the in terms of the memory, and so on, and then the victim would crash, right? So this is a typical denial of service. But this also can happen due to some of the lesser due to some of the various type of unhealthy practices that some of the administrators are using in terms of managing their DNS servers. For one example, if I would say, running open recursive resolvers in DNS. So open recursive resolvers are, earlier we explained about recursive resolvers. So recursive resolvers are, you are accepting queries from anyone. So that is why we call it open. Say, for example, consider that I'm an ISP, right? So if you are my clients, I should be only accepting the queries only from my clients. I should not be accepting queries from other parties who are really not my clients, or clients in a sense, my customers, right? So if I want to actually run a proper secure recursive resolver, I should be having some access controls. I should be actually filtering those queries based on my clients, right? Access controls, I should be having things like rate limiting. Rate limiting means if I see that a certain client is repeatedly sending same type of queries to same servers, then it could be, possibly it could be a bot, for example, then I should be actually limiting those type of queries as well. And that's what we call rate limiting. So these kind of best practices can be applied if you are a network operator, if you are running, or if you're operating your own recursive resolvers. If you run some open recursive resolvers, then obviously that means anyone can send queries to your server and then use your server resources and then spoof or spoofing, impersonate impersonate behalf of another party, and then send these queries to a wrong place. So if someone pretend to be another party, I will go and find an answer and send a response by thinking that I'm responding to you, but in actual fact, my response is not really going to you because you have spoofed someone else, you have impersonated someone else. So my response will go to another innocent party. And then if the attacker managed to send this query to many different recursive resolvers, say I'm only one, right? But if there are some millions of servers out there who are providing similar open recursive service, the query can go into millions of those type of servers. And then ultimately the response that the victim is going to get is huge, right? So easily, then as we discussed earlier, the traffic will become much more, the bandwidth will be fully utilized and so on. So the victim can be get affected. So this is what we simply call a DDoS attack. So these are all can, basically this is another case of abusing the DNS infrastructure as well. Okay, and then impact of hierarchical namespace. Now earlier we also discussed that DNS is a hierarchical namespace, right? So say for example, if a higher level domain is being abused or compromised, there's always possibility that the lower level domains can get compromised as well. Say for example, if the example.com domain is compromised, any subdomain under example.com, say for example, test.example.com subdomain can be compromised, right? So because due to the nature of the hierarchical system. So what else? What sort of other threats and abuses can happen in the DNS? Registrant compromises. This is also very common. I also mentioned to you about various email compromises happen, right? Email phishing attacks. So registrant can be compromised. So if the registrant can be compromised, then registrant's details can be compromised. And then say, for example, typically the registrant is given a certain portal access to the registrar. So normally if you have your own domain, the registrar would provide you a certain portal, a certain system for registrar so that you can log in and update your name server details. You can update your mail server details, your DNS name servers, and so on. So if your credentials are being compromised, then go and log in as yourself and change your DNS settings or change your name server settings or mail server settings and so on without you knowingly, right? And also it is also possible that to a worst case scenario, it is also possible that your domain could be transferred to a different other registrar, right? Because domains can be transferred. So if without you knowingly, if the domain gets transferred from one registrar to another registrar, then you will lose control to your whole domain, right? So this is why always, the registrar compromises can happen. If the registrar compromises happen, obviously not only one domain is in the risk. Many different registrants, many domains can be of risk as well, right? And similarly, if the registry get compromised, the things get even much worse, right? Because as we discussed, many registrars could be in a certain registry as well. So this is why actually, we also have to make sure that we apply different security mechanisms in different of these entities as well, right? Typically, coming back to that registrant compromise that I said, it's always an registrar compromises as well. It's always good to have the registrar locks, right? Because at least, if the miscreant, if the attacker is trying to transfer your domain from one registrar to another registrar, that would, if you have things like registrar locks, that would prevent that. And also actually, software vulnerabilities as well. There are plenty of software vulnerabilities that can happen. So typically, we should not be running the same DNS server software across all your DNS servers, right? Because in case if there is some certain vulnerability within the DNS software, and if you have the same software across your many DNS servers, that means you are running them as well, right? So it's always good practice to have different even DNS server software across your DNS infrastructure. Okay. There are a few questions have come. Let me actually pause here and try to go through some of these. Can I watch these webinar again on YouTube or any other platform? I think you may have to talk to the organizers here. Probably Vikram can answer that. Why can't we region lock websites using DNS? Like example, you gave example with.
Hi, Champika. Yes. Hello.
Yes.
My network has some issues, so that's why. Hello. Am I audible?
Yes, I'm. Is that Vikram speak? Hello. Hello, Vikram.
Hello. Just a moment.
Can you hear me?
Hello. Am I audible?
Yes, I can hear you.
Yeah. Hi, Champika. Hi. Yeah, please.
Can I go ahead?
Yeah, please.
All right. Okay. Yeah. So, yeah, I was just telling, going through some of these questions as well. Yeah, basically, I'm not sure what I mean by locking websites as well. I believe you are referring to the some of the security aspects that we discussed through registrar locks, right? So that is basically, that happens within our, between the registrant and registrars, right? And also actually different registrars do offer various security mechanisms in terms of your protecting your domain name as well. So always advisable to consider those security mechanisms as well. And then there are various other security mechanisms, like earlier I was talking about DNSSEC and so on. So this is to actually protect various aspects of DNS, like the DNS data, the integrity, the authenticity aspects, and so on. So we need to actually consider this whole, everything as a whole, right? So that is quite important. Okay, now just moving also forward, given that actually we are sort of almost into the hour as well, but I just want to actually highlight some of the DNS abuse initiatives that happen in the ICANN space, right? Within ICANN as well as also in the community. So then we can then go through some of these, and then if you have any further questions, we can take those. There is something called domain abuse activity reporting system. So this is actually to basically, report various type of DNS abuse across different top-level domain registries and registrars, right? So this system would provide good understanding of what sort of abuses do happen across those TLDs. Now, in this case, currently we are focusing on 4 type of DNS abuses. These ones are phishing, botnets, malware, and spam, right? So the whole idea here is that earlier I was telling you that ICANN has got contracts or contract, right? The top-level domains. Now, so which means we have something called centralized, zone, centralized, system, centralized system, actually to manage those zones. So we have access to those zones, for example, with the TLDs, the generic top-level domains. And then, so we can basically have some analysis based on those top-level domain zones, and try to analyze what sort of abusive activity happening within those domains in those TLDs. I'm talking the generic TLDs, the generic top-level domains, not the country code top-level domains. But now this is open to country code top-level domains as well. So for example, in case if anyone from any country code top-level domain registries are listening, say for example like .in, for example, in India, we can also now voluntarily participate in this because it is a voluntary process, because ICANN does not have any contracts with the CCTLDs. So this is why CCTLDs, if they want to join, they can voluntarily participate here. But with the contracted parties, like the generic top-level domains, their zones are already in this system. So the whole idea here is that we go through the whole zone and try to find what sort of badness is there in those different domains, and then report those back so that those appropriate registries can try to understand what sort of badness happening in their zones, and try to fix those, right? At the same time, the community can also get an understanding of collective responses, right? In terms of abuses, get a feeling of what sort of abuse is happening, and whether it is increasing over a period of time, or whether it is decreasing, whether we are doing good or bad, and so on. Okay, and also these sort of results can be reproducible for for your various research work and so on. So this is the whole idea. And also this system would consider a lot of reputation feeds as well. At the moment, there are lots of RBLs, or basically various reputation feeds about blocking domains and so on. So those feeds also comes in and we get the feeds from them as well, right? So if you want to have more information, you can go to this URL, which is listed here, right? You can find more information. So I just want to actually share some sample reports. So if you go to that URL, you can see monthly reports of DAR. So DAR is a very specific system to measure these abuse activities, okay, as we discussed. Here you can see actually the total number of domains identified over within a certain period of time. So this report is actually, I picked it from last December, the month of December. Okay, so this is the monthly report for December. You can see the amount of abusive domains that was detected, and also some of those in the legacy domains, like .com, .net, and so on. Those are the legacy ones, and then some of those are also actually the new ones. I also explained to you about the new ones, the new generic top-level domains, the ones that is more recent. So nowadays, actually, attackers, they also actually use these new top-level domains to create abusive activities as well. So in general, I told you that we are looking at 4 areas: spam, botnet command and controls, malware, and phishing. And you can see the breakdown of those type of different abuses happening in those areas. And also you can here in these reports, you can also see over a period of time, how these measurements, whether they are increasing or decreasing, and so on as well. By the way, I have only actually captured only few sort of measurements reports here. But if you actually go to the actual monthly report in that URL that I showed, you can see more detailed information and reports related to various DNS abuses. Now, this is also for you to actually get a certain understanding over the last 3 to 4 years, because we've been having this system for quite some time now. There are different security threats. You can see that over a period of time, if you take phishing, malware, and botnets, they are in the increase, right? Because we see more and more attacks have been coming, and that is why we see those attacks are in the increase over a period of time. But if you consider spam, it is on the decreasing side, right? So you can see the graph of spam over the last 3 years. It has been decreasing, mainly because a lot of network operators and ISPs and so on, even they attend to filtering spam quite a lot, right? Even in the server side, they do attend to a lot of filtering. So this also could be a possibility that we see that spam is getting better managed in comparison to phishing or malware or botnets and so on. One of the other sort of project initiative that I also want to highlight is something called measuring the health of internet identifiers. So when we say internet identifiers, again, we are referring to things like domain names, IP addresses. So these are all internet identifiers. So we try to measure the health indicators, or kind of how these indicators are being tracked over a period of time, and see whether are we doing better or worse, right? Again, this is to measure these kind of health indicators. We have to have a lot of collaboration with the community as well. So if you are from a university, if you are from a ISP, or if you're operating your own recursive resolvers, or if you're operating your own authoritative servers and so on, you can participate in these projects, right? And if you go to ithi.research.icann.org, you can see more details about this project as well. I will just show you a snapshot of things that what we normally measure as well, and then we can understand various behaviors related to these activities what we measure. Say, for example, the health of the root servers. ICANN is also actually a root server operator, right? And so we have the ICANN managed root servers. So when we can measure the type of various traffic coming into root servers, and when we measure the various traffic coming into root servers, we also see there are lots of queries that comes into root servers are actually what we call NX domain. NX domain means there's no answer, basically, right? So there are lots of queries that come that do not really have an answer. So this could be based on, because there are things called DGAs, domain generation algorithms. So which means a lot of fake domains are being generated by algorithms, by bots, basically. And then these queries gets to like, for example, like root servers, right? So there is no actual answer, because they would try various names. It could be they could be trying thousands of these names automatically through various algorithms, trying to find a matching domain, right? So there could be a lot of various unmatching domains could be ended up, and then those things come into the root servers. So you can see pretty much like 70% of the queries are actually NX domain type queries. We don't have an answer. And then we can also measure like DNSSEC deployment. Earlier I was talking about DNSSEC. So DNSSEC is a very important security mechanism that we should be considering. You should be considering, right? If you are a organization operator who operates authoritative DNS servers, you should be considering signing your DNS data digitally, right? So basically, you sign your DNS data. And then if you are a resolve operator, like an ISP or, any resolve operator, you should be validating this DNS data, right? Before you give an answer to your client, you should be validating whether you are really giving a correct answer. So this is pretty much, I assume that you understand the public, key cryptography, the fundamentals. So basically, you validate a signature using a public key, right? So, and then the public key has to be published. So this is the basic concept behind DNSSEC. And then, so if you deploy DNSSEC, we can also actually minimize many of those attacks what we discussed earlier. We can also measure, with the ITHI project, we do measure the resolver concentration, which means, when it comes to DNS queries, how much of these resolvers are concentrated. That means by fewer number of resolvers, larger number of queries could be handled as well. And then earlier also, we talked about the DAR system. So the DAR system also feeds into this ITHI as well. So you can have various sort of measurements about different types of abuses also. Okay. Another initiative actually is also what we call, this is by the community, ICANN community. So there is an initiative called Domain Name Security Facilitation Initiative. Simply, this is called DSFI. So this is there's a technical study group. So there are various DNS experts who are from the community. So they have volunteered to actually provide, do these studies and provide recommendations to ICANN as well. So there is work related to these different recommendations. So you can, feel free to, look into more details about that as well. And then also actually, I told you about there are ICANN contracted parties like registries and registrars. So they also have a project, related to the DNS, handling DNS abuse. There's a certain DNS abuse framework that they have defined. So if you go to dnsabuseframework.org, you can again find more details about this this framework. Also, what are the indicators, what are the guidelines within this, and then how we can define the DNS abuse. Okay, before I really go into, I also want to touch a little bit on the DNS abuse during this, especially during this pandemic time, during COVID-19, because always when there are some certain things happen in the society, socially, depending on the different incidents, always the abuses also can go up, right? Especially COVID-19 has affected the whole world, and then a lot of activities has happened now because people now doing online. So many of these attacks started happening, and the abuse have increased. Let me also actually, in the meantime, go to some of the questions which are coming up. How DNS compromises in farming to be prevented. So when it refers to the farming, basically, farming and phishing, these terms go hand in hand. So farming is basically, you through email, or for example, it could be through a spam email, you are given a certain website, right? You are given a certain website, so you might just click a link, right, and then go to the wrong website, right? And then through phishing, the information can be captured through that website, right? So anyway, the reason behind this whole thing is that you are going to a wrong place, right? As a user, you are going to a wrong place. So from a DNS point of view, how do we identify that? How do we understand whether we are going into a wrong place? That can be prevented by DNSSEC, the mechanism just, I was just explaining to you earlier. So in DNSSEC, before the recursive resolver give an answer to a client, recursive resolver can validate whether this answer is correct or not. Say, for example, answer means the IP address. Remember, I explained to you earlier. It is the recursive resolver that gives the IP address of the website to the client. But if it's a phishing site, then the recursive resolver could be giving a wrong IP address to the client. But how do you know whether it's a wrong address or a right address, right IP address? So this can be validated by checking the signatures or validating the signatures, the digital signatures. So if you can do DNSSEC validation, then we can avoid that sort of situation, right? So there are mechanisms available. There are mechanisms available to avoid that sort of compromises. Okay, so I hope that I've answered that question. All right, now just moving into the DNS abuse during COVID-19, as I explained to you. Now here, first of all, we have to understand, what sort of keywords that the attackers they use, especially during this time. I mean, this could be common to any social incident that can happen, but in this specific case, I'm taking an example, COVID-19. So there could be several domains registered with the term COVID, for example, or they could be using a term like Corona, or pandemic, or things like this. And then this can be even further, this analysis can be actually further broadened up by using also some other considerations in the algorithm. Say, for example, like adding some more details, more boosting seeds into the algorithm. Say, for example, we can consider the translation of into a different language, or because we also know that there are some IDN domains could exist. So this COVID term could be instead of this O, you could have a 0 or another similar looking character from a different language script, right? Or it could be the Punicode, the IDN, the label that they could be using. So there could be various combinations or various considerations that we can look into in this case. So by looking at all options and going through all those zone data, remember I told you that we can go through the different generic top-level domain zones in the centralized zone database, and then we can analyze all those different type of domains and see what sort of badness is there in relation to this COVID situation. So with this, actually, it has been identified, especially like during the last year, from January to November, there have been something like 250,000 domains identified. So in this blue line, you can see, this is actually in the last year. Now, by the way, this is the top level domains, right? So we are not considering here the country code top level domains, as I said earlier, because only very few country code top level domains have volunteered at the moment, but it is open to more and more. And we more country code top level domains would be joining to this as well. So considering the existing top level domains, right? So we have seen something like 250,000 or so, close to about that domains identified in this blue line. So you can see in the middle of last year, this has really gone to the almost peak, and then it has been decreasing because a lot of registries and registrars, they have started handling these sort of abuses. And then in the last 6 months, from May to November or so, around 150,000 cases, but then out of that, around 9,000 has been identified with some sort of abusive activity. So this is what you see in the red line here. And out of that, around 2,500 or so with high confidence reports. So you can see that domain abuse is really happening. right? These are all real statistics and so on. And so there have been something like 2,500 high confidence reports. So these reports have been sent to the registrars and registries so that they can actually take appropriate measures related to those abusive domains. Something also actually came up actually out of all those studies or those work that has been done. Almost like 60% of the domains that was identified out of these actually had some common or 4 keywords that consist of COVID, mask, corona, and virus. So you can see that, that is always possible, especially during this pandemic time, during this COVID-19 time. A lot of miscreants, a lot of attackers could be registering domains related to these sort of terms, and then have some abusive domains, phishing domains, or trying to do some abusive activity as well. And remember that there could be some IDN domains as well within these as well. Okay, so this is something for you to note, especially given the current COVID situation as well. I think this is something I wanted to actually highlight within this presentation, within this sort of workshop that we went through now. Also, actually, let me revert back to the question. Yeah, so now there are some questions about botnets in general. And then there are also actually about offenses between web jacking and web squatting, defacements, all maybe. Yeah, so obviously, like, botnets can be used for, botnets is simply basically a code, right? A program, a simple, small program that could actually target it for a specific, activity, right? This, if this is done for a bad purpose, obviously, then it relates to the abusive activity that we have been talking about, right? And then again, these bots could be not only related to DNS, but for many other related cybercrime, activities as well, other cybersecurity related contexts. But here, specifically from DNS point of view, I gave you some examples. Say, one example could be that someone could write a code or a bot, for example, to change your DNS settings, right? So it is a small program written to change your DNS settings, DNS server settings. So that, and then this could be incorporated into a certain website. And then once the user is visited, once the user visits this particular website, you obviously the attacker will use some other means letting the user visit this website. That could be done through a spam, that could be done through a certain, other promotional activity or anything, right? And then the whole idea is that the user visits this website that has got the botnet or the malware, right? And then once that gets downloaded into the client device, the program is designed to actually change the DNS settings, right? So it will just change the DNS settings, and your queries then will go to the servers that is being set by the attacker, right? So this infrastructure could be managed by attacker. So attacker can see all the queries, attacker can see all the attacker can also actually, if attacker is controlling the recursive resolvers, attacker can give the answers to you. So it can, attacker can do all sort of things, right? So that's the generic idea about how the botnet works, and now in this case, of course, specifically related to DNS in this case. Okay, I hope that clarifies your query. And then also there was a other question about the web defacements and so on. Yeah, these are all kind of different type of abusive activities that can happen in the cyberspace, right? Now again, some may not relate to DNS, and some could be related to DNS. If it is anything related to basically abusing or misusing the DNS servers, then or the DNS infrastructure, then obviously there is a direct relation to your DNS. But then there could be also, there are various other related, cyber related things that can happen in terms of the security issues. But the whole point, but the bottom line, what I would want to actually give you is the good cyber hygiene is very important, right? I'm just now going beyond DNS here. Good cyber hygiene is very important. So he's always having good security policies in organization, and then having proper physical security in place, even having good all those good practices, even proper policies, proper practices, and security mechanisms, and mandates within the organization. Say if you are procuring or buying certain products or software, hardware, and things like that, following good practices, compliances, all these things are important in terms of preventing these sort of abuses. Okay, I hope, because the question is sort of more generic, so that's why I sort of responded to you in more generic way as well. So anyway, to summarize the DNS abuse aspects, what we discussed, I think we went through a number of things. We went through how DNS work, and then how the DNS database look like, hierarchical, distributed type of structure, and then the root servers, the root zone, and then the top level domains, and then the different type of top level domains like IDNs, the new generic top level domains, and so on. So over the years, how it has been evolved. So the attacks also have evolved quite a lot. And then we went through various type of attacks that can happen, namespace related attacks, and then the hijacking type of situations, and then the data integrity related, protocol related situations, and the attacks that can come in due to the lack of security mechanisms which are in place in the infrastructure, and then also actually the compromises that can happen in registrant level, the compromises that can happen in registry levels, and then different the server side issues as well, software vulnerabilities, all those kind of things can lead into some certain abuses as well. And then important thing is, importance of handling those abuses, understanding if you find some abuse, where to lodge your complaints. For that, we have to have some understanding about different entities in the whole system, whole DNS ecosystem, like resellers, domain name resellers, registrars, registries, even ICANN, compliance, all these different entities, right? Having some understanding about those also would help you to identify, how to, where to actually lodge those abuse complaints. And then also following good practices, which is also important. And an important thing is, again, managing or having a proper good DNS infrastructure, as well as the whole cyber space to be quite hygiene in terms of your organization, having proper policies, having proper guidelines and so on within your context, right? Also, we went through various situations due to various projects as well ongoing. I also explained to you related to the ICANN initiatives like DAR, the Domain Abusive Activity Reporting System. Also went through ITHI, and also various other community initiatives like DNS Security Facilitation Initiative, and also things like DNS Abuse Framework. And then went through some aspects related to the current situation like COVID, trying to understand that these sort of abuses can happen much at a larger level in a situation like this. So I hope that you have got some understanding about various type of abuses do happen in the DNS space. If you have any questions, I'm happy to answer now, or feel free to be in touch and have you can see the contact details of us. You can see more details. Also, you can tune into various ICANN social media channels as well to get more updates. Also, we do lots of capacity building activities as well. If there is a demand, we can conduct more capacity building activities also into very specifics of what we discussed, like say, for example, if you want to know more about DNSSEC, we do provide some capacity building and so on. Also be in touch with Samiran as well, and so he can even provide more details. Thank you very much. If you have any questions, I can take now, or we can probably end the session here. Okay, let me go through I believe all the questions are being taken. Vikram, over to you.
Hi, this is Samiran. Champika, I just wanted to add just a little point for those who are listening.
Yes, Samiran.
Yes, thank you for this presentation, and I think it was quite comprehensive, but I'm sure there'll be even more questions. And thank you for sharing your email ID. For those who wish to keep in touch and get some more clarifications, I think you can write to Champika on his email in the future. Thank you. Vikram, are you there?
Yeah, actually, he's joining in a while. He has facing some network issues. Joining in a while.
Okay.
Hi, am I audible? Hello.
Yes, you are.
Yes.
Yeah, hi. Thank you, Champika. Thank you for the wonderful session that you conducted. And I must thank ICANN also for actually jointly hosting this workshop for our participants and our volunteers. So thank you, Samiran. Thank you for your feedbacks, and thank you, Champika. It was very nicely conducted. Although I missed most of the part due to the lag in my Wi-Fi. I was not able to connect. I don't know why this happens usually. So most of it was missed by me. But yes, I have the recording. I'll actually go through it, how it went. I hope all the answers, all the questions were answered by Champika. And participants, if you have any more questions about the workshop or anything, you can surely mail. We have the email ID of Champika, and you all have our email ID and our helpline number. You guys can always connect to us.
Vikram, this is Samiran.
Yeah, hi Samiran. Yeah, please tell me.
There was one question whether this video will be available.
Yes, it will be. Yes, it will be. So post some minor edits. We'll be posting it on our YouTube channel, that is CyberPeace TV. So this video will be uploaded on CyberPeace TV by end of this week or Monday morning.
Fantastic.
Yeah.
Okay, thank you.
Thank you, Samiran. Thank you for joining.
Thank you, and we'll see you later.
Thank you, Champika. We would surely meet.